Hello, everyone. Welcome to a session of Data Science and Artificial Intelligence in Africa. Today, we have Rockefeller, who has an interesting story to his name and his background as well. Welcome, Rockefeller.
Thank you very much, Tatinda. And good morning to all your viewers. Good morning to everybody that watches this video. It's my pleasure to be here, and I hope we're going to have a very interesting discussion and insightful discussion as well. Thank you.
Thank you. So maybe you can start by telling us who you are and a bit about your background and how you got into AI.
Okay, that's quite a fundamental question. And first of all, my name is Rockefeller, and only Rockefeller, by the way. So I was born and raised in Cameroon, in a little town called Douala. So, and my current background, I'm doing my PhD in artificial intelligence applied to climate sciences. But my background used to be in physics. I actually did my undergrad in physics and also my master's in physics. And it's after that I actually started my data science journey. But if one wants to understand how I found myself in the AI field, it actually started when I was a kid. So it's only when I look back that I see that the dots are connected, but it wasn't evident at the time. So the story started with my father. You know, when I was 4 years old, and it was about the time for me to go to school, like any kid in the neighborhood, my dad decided that the educational system at the time wasn't suitable enough for me and my brother. So I was actually homeschooled, which is quite unusual around Africa. Yes. So I was homeschooled for 10 years. So being homeschooled is normally something that you expect from I would say, rich people or people, you know, financially loaded. But we're actually a very modest family. It's just like my dads were that type of person that believed that if you want to know something, just go out there and learn it. So we decided that, hey, I'm going to resign from this job. And my mother became the breadwinner, and he focused entirely on, you know, educating me from primary school all the way up to grade 11. So the first time ever in my life that I stepped foot in school, that I wore a uniform to go to school, it was when I actually was in grade 11. So I completed grade 11, I went to grade 12 and university. That's it. And, you know, during the time that I was homeschooled, I basically developed the art of self-learning. You know, most of the things that we were taught actually were from my dad, and I also did a lot of self-learning. So which means learning things through myself, to experience all of that. And now when I finished during my master's degree in physics that I was doing in the University of Yaoundé, and the university organized a campaign, like a survey in a southern part of my country, where our job was basically to go out there and record collect data about what? Data about, because I was doing geophysics. So we went for this campaign to collect data about, you know, Earth, about the underground, in order to study the properties of rocks and things like that, because that's what geophysics is all about. It's actually the application of physics in the earth science, basically. It's like geology, but with the tools of physics. So, and when I went there on the field to collect the data, and with my colleagues and my professors, what happened is like, I was lucky enough to be the person that had the sheets, that had the actual sheet I was taking when collecting all the information. I started realizing that was how the first click happened. I started realizing how much important is the data collection process, because it was sensitive, such a process. And I noticed that if, for instance, I record the wrong value, that can damage the rest of the survey because the wrong value that I recorded. So people actually trusted me with this data collection process. So, and that survey, that journey actually taught me the importance of data collection, how much if you spend time in quality time in collecting data. And when we went back to the university, now I had to analyze the data in order to write my dissertation, my MSc thesis. And I also realized how much we lack tools to analyze those data that we collected. The only thing we knew back at the time was just, you know, putting data into Excel and get some little curves and done. But actually, no, when I read scientific paper, the actual analysis went far than that. But I wasn't equipped enough. That's why I told myself that I need to bridge this gap. I need to learn the tool that will help me analyze data. And I was lucky enough the year after to be selected by the African Institute for Mathematical Sciences for a scholarship in Masters for Mathematical Sciences. That's actually where I got to discover data science and AI. And I realized that not only I can use the tools of data science to solve my geophysics problem, but data doesn't only come from that field. Data pretty much comes from everywhere. We have data in statistics. We have data in computing sciences. We have data in social sciences. We have data in religious sciences. We have data in biology, for instance. You can see how much you can collect data from pretty much every field. Now the job was now to learn the tools. And I got interested in learning the tools because not only I could bridge the gap into solving the geophysics problem, but also be able to help other fields in solving their problem by the use of those techniques, using those data. That's basically how I find myself in the AI world. And ever since, I haven't stopped, went for a data science position. I also started teaching data science, and all the way up to now that I'm doing my PhD in data science. That's basically the journey.
That's quite an interesting journey.
Yeah.
Considering where you started, has your dad been like a huge influence in your career, the choices that you've made?
Yeah, very much. And something that you also need to know is like people, whenever I tell them the story, they think that my dad was a teacher or a lecturer somewhere. Actually, no. My dad was just I don't want to say civil engineer, but his job was just to build houses. But he wasn't an engineer. He didn't have any engineering degree. Back in the days, how the educational system was back in the days, like anyone that was that went through the process of education could basically have an idea about around pretty much a lot of fields. It's not like today where things are specialized that, for instance, if you know about clinical psychology, you might not know about industrial psychology, for instance. But back in the days, some people might know things around math, physics, biology, art, and everything, but not to the deeper level, but at least some superficial level. That's the knowledge that my dad used to actually teach me the basics. So he was basically the one that taught me how to write, how to read, how to think, how to count, and all the way up to my secondary school education. And that process has been quite instrumental in teaching me how to learn with myself, develop the self-learning aptitude, which is quite important in data science because most things that we learn in data science is just through self-learning. That's why I say that process actually helped me in my current career.
Yes. So in terms of self-learning, sometimes, when you're learning on your own, you end up going to like different, you don't get to specialize, like you look at so many different things and you try to make like a combination of those things. Could you say that you are someone who is good at the general aspects of like AI and data science, or you specialize in something like a certain field or area?
That's quite a good question. I think at first when I actually introduced myself to the world of data science, my aim was just to bridge that gap, get the tools to solve my problems in geophysics. That's the only thing I was interested into. Only to realize that data doesn't only come from that field. It comes from so many fields. And I started telling myself, okay, instead of just specializing in one field, let me just see the bigger picture. And it was about the time where people were flooding the internet with things like, it's going to be the next revolution, AI is going to change everything, data science is the future, is the next oil and everything. I just decided now to move away, not only from learning that for geophysics, but actually understand the algorithms, the techniques, in such a way that I can team up with people from different fields and still trying to be helpful. So I'm basically that type of person who is mostly specialized in the algorithm of it, the core part of it, not in that one direction. Even though I'm doing my PhD in the area of climate science, but my interest is much more on understanding the techniques. Not necessarily the application narrowed in one field. Yeah.
Okay. So can you explain more about your PhD? What are you working on and how is it related to AI?
Okay, interesting. Basically, my PhD is in the area of the application of one method in AI called deep learning that comes with neural network in climate sciences. So basically, my job on a daily basis, my job is to build or to develop AI model that can try and forecast climate products in such a way that the long term will be trying to forecast climate, weather, if I could use that word, or to see the bigger picture dynamical system, that system that evolves with time. So my job is to develop such things, some model that can learn from the data, because we have data nowadays. We have data from the wind, from the sun, from sunshine hours, from the air temperature, from atmospheric pressure. Can you collect those data, those time history of data, develop a model that can learn from those data and try to forecast the evolution of those systems? That could be quite tremendously helpful for those who want to forecast the climate or forecast the weather. That's basically what my PhD is all about.
Okay, so for some people, they might try to understand, like, even before, we used to have weather forecasts. We used to have people on the news telling us what the weather would be like. How is that different from what you're doing now?
Okay, that's also interesting as a question. Like the existing models that people use to forecast the climate, they are mostly physics-based models, which means, first of all, they are very difficult to build. They require a lot of computations to be built and also a lot of resources even to be built. Those models are actually based in laws of physics. And the thing is, we are in a situation where the forecast is not that accurate, first of all. And at grand scale, the physics-based model, I don't want to say fail, but they are not strong enough. And we're actually need an alternative. Instead of just relying on the laws of physics, which is quite fundamental in order to focus the climate, what if we try and listen to the data themselves? So we are just taking different approaches, which is cheaper. As we speak, people that focus the climate, they base themselves on physics-based model, which is the finest, which is great. But what we want to do is to develop an alternative that could be cheaper. That's why we call those techniques data-driven approaches, because we actually use data in order to forecast the future, not actual, physics law. That's basically the difference between the two. So my alternative will be cheaper, but hopefully we can get the same level of accuracy. But that's quite ambitious, but that's actually the aim. That's the difference between the two. Yeah.
Okay, so in general, you're saying like these AI or data-based methods are actually cheaper and more efficient compared to what was used before.
Yeah. That's basic. Yeah, that's basically the difference between the two. Yeah.
Okay, so I'm curious to know now that you said your job is to develop models. So what do you do on a daily basis when you get to your office? What do you do? What does a day at work look like for you?
Okay, so maybe I forgot to mention that apart from handling a PhD, research career, I'm also a data science consultant. So which means I'm trying to handle both careers at the same time. So on a daily basis, basically what I do when I go to the office, like everyone else, start by reading emails and answering emails. And the second thing I do is basically to tackling research papers. It's like, to be able to come up with your own research paper, you also need to read what other people have done. So that's basically what I do. And when I do that, I can now focusing on my research, because at the time, for instance, we are not only using existing deep learning or AI model, we are trying to come up with our own type of models, which can be an improvement of the existing ones. So what I'm basically doing is trying to develop the mathematical model of it on paper using my pen and trying to transcribe it into computer programs, which can be coded in languages like Python or PyTorch or things like that. And when I've done that now, since I have access to real-world data that comes from meteorological station, then I can use those data now to feed my model with in order to see what comes out of it. And I fine-tune it and I tweak it and I change it. Sometimes I fail, sometimes I have little success, and so on. And when the material is ready, I can now report it to my supervisors or present it at conferences in order to receive feedback and improve it again. That's basically how the day is being spent. And when I do that, and the other side now, when it's done, and I can now focus on my other activities that involve consulting for companies.
Yeah. Okay. So how important, I understand from your PhD side, the mathematics behind the methods in AI are important, right? But how important is it when it comes to consulting now? Because now you're in the field and you're working with businesses. How important is mathematics in that?
Definitely, I don't want to see that important, because what most people in the industry, they only care about results. They have little care for how many neurons do you have in your models, what techniques do you use. They don't really care about those things. They only care about the accuracy. So, which is a good thing, which can also turn out to be a bad thing, to be not so a good thing. So basically, I need to, first of all, always try and differentiate between what is like doing data science industry and data science in academia. In academia, it's always all about, having the finest model, exploiting the accuracy, try and prove theorems, try and understand the why and why and why. While in industry, basically you pick up the finest model that exists out there, you try and understand the code, and you feed the model with the data and try and see the outputs. And now you gather the outputs in a nice, maybe PowerPoint format, and you show it to your clients. And so they give you feedback and you improve it again and again and again. So that's basically what happened. Yeah. But definitely there's a distinction. Mathematics plays a little role in my industry career. It plays a huge role in my academic career. But it's always a challenge to actually, find the right balance between both. Yeah. But I guess that's what comes with having a career in data science.
Okay. So my next question is, what advice would you give to someone who wants to do the same thing that you're doing? Maybe someone in high school or someone who's doing their undergrad. What advice would you give them?
Well, at the first place, at the beginning of my statements, I said that it's only looking, back that the dots are connected. But from the time I was starting this career, I couldn't see anything. I was just moving forward. So, first of all, there's always a reason why someone wants to start a career in one field. There's always a reason. My advice is, first of all, try and identify the why you want to start a career in this field or that field. Because that reason will be the seed that will keep you going when you come across difficult time. So the moment you've identified that reason, now try and grow it. Try and grow that seed in you. Try and grow some passion about it. And once you do that now, go out there and look for mentors, look for help. Now that's where my advice comes handy. So for someone that want to do a career in data science or AI comes with passion for self-learning, first of all. That's why, for instance, my homeschool journey has been quite helpful, because back then, they love self-learning. So you should be ready. You should always be, ready to go for more self-learning, and also know that frustration is part of the process. Some days will be rocks, some days will be diamonds. And also, spend some time learning. Give yourself a chance to learn. Give yourself some chance to get to learn what other people do in the field, what other fellows do in the field. Like hone your skills, for instance, in hackathons, in real-world projects. And what maybe the most important advice is, like, the moment you feel like you are ready for the world of work, don't aim for jobs that will give that comes with high salary when starting your career. No, you might end up not learning a lot. You can be lucky and find a job that actually mixes good salary and also a rewarding experience on the workplace. But out there, especially in the African continent, some jobs that pays a lot, they don't really comes with actual learning, especially for beginners, for those who begin their career. First of all, there are so many interesting projects out there that you can bump into, and they will teach you lots of things. They'll help you grow a lot of experience, but they might not be necessarily rewarding in terms of finance, for instance. But one thing about those things is, like, you will learn a lot. That's basically what happened to me. I worked for one or two companies where I wasn't that paid, but the amount of experience I developed in those companies turned out to be quite useful moving forward. So that's my advice for people that want to start a career in it. Self-learning is the key. Grow the passion. Know that frustration is part of the process. Hone your skill on hackathon and real-world project, and try and see what other people are doing in the field. So if you combine those, you basically have a nice recipe for you to have a successful career in the field. And you have to be an eternal student, an eternal learner. We learn every day. The moment you stop learning in data science, you're basically out of the game, because it's a field that is currently advancing at a very high pace. It's difficult even to catch up the train, but you have to find a way to, always try and get some little, make some little progress on a daily basis. That's basically the advice I would give for someone who starts. Yeah.
Okay. Thank you so much, Rockefeller. I think we are now running out of time. But I'm really grateful that you made time for this, and thank you for your advice and information about your background and how you got into this. Thank you so much.
It was all my pleasure. It was all my pleasure.